In these problems, we're going to continue to solve linear equations. However, you'll notice that when you go to see where the variable is, so in this case we go here and try to see where the x is, notice that there's a lot more going on. On this side, I have x is being multiplied by 3 and also has 2 being added to it after that. So when we're trying to get the x by itself now, I'm going to have to get rid of both the 2 and the 3 because they're both on the same side of the equation. Does it matter which one you get rid of first? Absolutely. Think about how order of operations normally works. The first thing you'd have to do normally would be to do 3 times x, and then after that we'd have to add 2. So when we're solving an equation which is basically undoing everything that was done before, we need to undo them in opposite order. So if you kind of want to think about doing PEMDAS backwards when you're trying to solve, if that helps you, that's really the essence of what's going on here. The multiplication hangs on for a lot longer, and the addition and subtraction is the weaker link, and so we need to get rid of it first. So the first thing that we would do here, because there's a plus 2, I'm going to get rid of the 2 first, and I'm going to do that by subtracting 2 from each side. Here, plus 2 and minus 2 drop out and leave me just with 3x on the left. On the other side, I have 14 minus 2, which is 12. So I have a new equation, and now it's simpler. Notice that here I have x. Now it's only being multiplied by 3. I still have to get rid of that 3 before I'm done solving this equation. That right now the x is being multiplied by 3, so to undo it, what I'm going to do is divide by 3. So I'm going to divide by 3 on each side. Here, 3 divided by 3 gives me 1x. On the other side, 12 divided by 3 gives me 4. So x equals 4 becomes my final solution. And again, you can always check that answer by plugging it back into the original problem. So for example, 3 times, instead of x, I just found out it was 4, plus 2. And if you do 3 times 4 is 12, plus 2 is 14, and sure enough, that checks out exactly right in my original equation. So you can always know if you did it right when you're done if you want. All right, so let's take a look at number 8 here. This time I want to get y by itself. It's right here. There's a 10 and a minus 4 on the same side of the equation. So those are the things that I need to get rid of. I always want to get rid of anything that was added or subtracted first, and in this case that means I've got to move the 10. Right now it's a positive 10, so to move it I'm going to have to subtract 10 from each side. Here the 10 minus 10 will give me 0, and that will drop out, and then I'll have negative 4y on one side of the equation, and on the other side of the equation 2 minus 10 will give me a negative 8. Now to finish getting the y by itself, now it's being multiplied by a negative 4. So to get it by itself, we're going to divide both sides by negative 4. Negative 4 divided by negative 4 is a positive 1y, which is what I need. And on the other side, negative 8 divided by negative 4 is a positive 2, which is going to be my solution to that equation. Couple of things that I want to point out here in terms of this. Notice that the multiplication stays the longest. Also notice that this was a minus 4y, and that minus stays with the 4. So keep track of any signs that are in front of those values, because they do come down as we work our way through these problems to solve. Another thing that I kind of like to point out is that when I'm looking at my variables and I'm trying to decide how to get rid of things, I often use physical proximity. What that means is if it's close to the x, it's going to stick around for longer because it's a tighter piece of the order of operations. That's why things that are added or subtracted have this level of separation from the x, so we have to get rid of them first. It's kind of like you putting your socks on and then your shoes, so when you take them off you have to take your shoes are the farthest away and then you can get to your socks that were the closest. So it's that idea is really helpful. All right, so now let's go ahead and take a peek over here at question number 9. This one's different from other ones that we've done so far. I'd like to get the x by itself. There's a minus 3 and there is a 7 there. And I'd like to be able to try to work to get that x by itself. Something that if we have parentheses, I can't really add the 3 right now because it's trapped inside the parentheses. So what I'm going to, one of the things that you can do to help you in these situations is to use the distributive property. This allows us to rewrite the equation with no parentheses in it, and it will make it easier for combining or solving for your variables as you need to. So in this case, if I take that 7 and multiply it by each thing inside, 7 times x gives me 7x, and 7 times a minus 3 gives me a minus 21. And now I have this as my new equation. I'd like to get, now I have no parentheses, everything is fair game, and I can do some work to get things by itself. So there's my variable x. I'd like to get it alone. And so I have a times 7 and a minus 21. So we'll get rid of this farthest away thing first. It's a minus 21, so I add 21. And again, remember, anything you do on one side of the equal sign, you have to do on the other side. So that crosses out to leave me with a 7x, and the 8 plus 21 we can add to get 29. Now to finish the problem, I have 7 times x, so I can divide both sides by 7. And that will get me x equals, when I do 29 divided by 7, notice it does not go in evenly. And so we just try to reduce it if we can. This one cannot. And you are absolutely fine to just leave that as an improper fraction for your solution. Okay, moving on to question number 10 here. Notice again we want to get the x by itself. In this case, there's a 4 over here. It's a positive 4, so to make it be 0, what I'm going to have to do is subtract 4 from each side. 4 minus 4 goes away. That gives us 0. But notice that there's still a negative in front of the x, so that negative does have to come down with it. It hasn't gone away. On the other side of the equation, I have 6 minus 4, which is 2. Now, keep in mind our goal was to get the x all the way by itself. Right now, because of the negative that's out in front, it is not by itself yet, so I'm not finished with the problem. Probably the easiest way to think about this, remember if there's no number in front of it, it's a 1, so we can think of this as negative 1 times x. So if we divide both sides by negative 1, we'll be able to finish getting the x alone. In this case, the negative 1 divided by negative 1 gives me that positive x that I need, and on the other side, 2 divided by negative 1 gives me a solution of negative 2. Here on this one, I want to get the p by itself. It's being multiplied by negative 3 and has 12 added to it. Always get rid of the plus or minus first. So I'll subtract 12 from each side. 12 minus 12 gives me 0. Bring the negative down along for the ride, so that's negative 3p. And on this side, negative 11 minus 12 gives me a negative 23. I want to get the p by itself, so I divide by negative 3 on this side, and I divide by negative 3 on this side. The timesing by negative 3 and dividing by negative 3 are those inverse operations, and so we get that p all the way by itself. On the other side, I have negative 23 over negative 3. It does not go in evenly, so I can just think of this as reducing a fraction. 23 over 3 has no common factors, so we can just leave that. Now notice that we had a negative on top and a negative on the bottom, and a negative divided by a negative does make a positive, so I would just leave this solution here as positive 23/3 for p. For the last problem here, we want to get m by itself. It's being timesed by 2/3 and adding 5. We do want to go ahead then and subtract 5 from each side. In this case, 5 minus 5 is 0, which is gone. I still have this 2/3 m. And on the other side, I have negative 5 minus 5, which is negative 10, so I can bring that along. Now, at this time, I want to get the m by itself, and it's being timesed by 2/3. So what I can do is divide by 2/3 on both sides of the equation. I'd like to show you a little bit of something different you can do here that's sometimes a little bit cleaner and faster as you go through to solve problems. Remember that dividing by 2/3 is the same thing as multiplying by 3/2. So what I can do here instead is multiply by 3/2 on both sides of the equation. On the left side here, notice that when I do 3/2 times 2/3, the 2's cancel and the 3's cancel, and I'm left just with m. So I have 1m after dividing those common terms out. And then on the right side, I just have negative 10 times 3/2, which is what I need to do to get to my solution. Don't forget that when we're multiplying fractions, it's good. We need to make sure that everything's a fraction, so put that negative 10 over 1. We do see that 2 will go into both the top and the bottom there. 2 goes into 2 once on the bottom, 2 goes into 10 5 times on the top, and then that was a negative 5 times 3, which gives me a negative 15 over 1, or just negative 15 in the end for my value for m.